Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Databases are structured systems designed to store, retrieve, and manage data in an organized and efficient way. They use predefined structures to ensure information can be quickly located and accurately maintained. In the Tech Plus certification, you are expected to understand both how databases function and when they are the preferred solution over simpler storage methods. This episode examines common use cases, storage behaviors, and structural differences in databases, along with how persistence and performance are handled in day-to-day IT operations. The core purpose of a database is to organize large volumes of data into clearly defined formats so it can be managed effectively. Databases make it possible to quickly access needed information through queries, while applying rules to maintain accuracy and prevent conflicting entries. They are built to support multiple users at once, enabling teams to collaborate and scale without losing performance or control. This combination of structure, speed, and integrity is what makes databases a foundational IT tool. Creating and inputting data into a database can happen in many ways, from manual entry in forms to automated imports from other systems. Data may also be collected through sensors, applications, or integration tools that feed information directly into tables. The quality of input at this stage has a direct impact on reporting accuracy and system performance. IT professionals often support users by clarifying required formats, validating entries, and troubleshooting problems that can arise from incorrect or incomplete data. Querying and data retrieval are the processes of requesting and receiving specific information from a database. A query might be as simple as listing all customers in a region, or as complex as joining multiple datasets for a performance report. These queries drive dashboards, reports, and application features that depend on accurate, timely results. The efficiency of a query is influenced by how data is indexed and structured, and knowing how this process works helps IT teams troubleshoot performance issues more effectively. A flat file differs from a relational database in both structure and capability. Flat files store data in a single, often unstructured document, which can make them easier to edit but slower to search and less capable of handling large or dynamic datasets. Relational databases, on the other hand, store data in tables with defined relationships, enabling fast lookups and complex queries. For environments with growing data and multiple users, databases scale more effectively and provide better reliability than flat file systems. Records and fields are the building blocks of database tables. A record represents a complete entry, such as a single customer or a transaction, while fields represent individual attributes within that record, such as name, date, or identification number. Multiple records are stored in the same table, following a consistent structure so that queries and reports remain accurate. Consistent field naming and correct data type assignment make it easier to maintain and retrieve data without errors. Database speed and performance are influenced by both design and ongoing maintenance. Indexed fields allow common queries to return results more quickly, while optimization techniques such as sorting and filtering help reduce unnecessary processing. Avoiding duplicate entries and structuring data to minimize redundancy improves efficiency. System monitoring tools can identify bottlenecks, allowing IT teams to take proactive steps to maintain high performance even as data volumes grow. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Data persistence is a defining feature of databases, meaning information remains stored and available even after the system is shut down or restarted. This long-term retention ensures that records can be referenced, analyzed, or updated at any time in the future. Persistent storage also supports backup and redundancy strategies, which protect data from loss due to failures or corruption. Unlike temporary memory operations, which disappear when power is lost, persistence allows databases to serve as reliable repositories for critical business information. Structured data relies on a schema which defines how tables, fields, and relationships are organized within a database. A clear schema improves readability for developers and administrators, while also enforcing consistent naming and data types. Well-designed schemas reduce redundancy, improve search speed, and make integration with other systems more straightforward. In IT environments, schema documentation becomes essential for troubleshooting, scaling, and ensuring that different teams work with a shared understanding of the data structure. Maintaining data integrity involves enforcing rules that ensure accuracy, completeness, and consistency across all records. Validation rules can require certain fields to be filled, enforce correct data formats, or prevent duplicate entries. Integrity constraints ensure that relationships between tables remain valid, such as preventing the deletion of a customer record if related orders exist. High data integrity increases the reliability of reports and analytics, directly impacting the quality of business decisions. Modern databases are designed for concurrent access, meaning many users or applications can work with the same data simultaneously. This capability requires systems to manage potential conflicts, such as two users trying to update the same record at once. Tools like record locking and transaction control help preserve data accuracy during simultaneous operations. Scalability features ensure that databases can grow in size and complexity without losing performance, supporting the demands of expanding organizations. Databases can be hosted locally or in the cloud, and each model offers different benefits. Local databases are managed on in-house servers, providing maximum control and often faster access within the network. Cloud databases are hosted remotely, offering automatic scaling, built-in redundancy, and managed maintenance by the provider. Many organizations choose hybrid setups, using local databases for sensitive data and cloud solutions for scalable, distributed access. The choice affects cost, security, and operational flexibility. Backup and recovery strategies are critical for preventing data loss. Scheduled backups store copies of data so it can be restored in case of hardware failure, corruption, or accidental deletion. Recovery tools allow systems to return to a previous working state, minimizing downtime. Regular testing of backup and recovery procedures ensures that the process works as intended, protecting both business operations and compliance requirements. Access control in database systems determines which users can view, modify, or delete specific records. Permissions are often based on user roles, with administrators having broader access and standard users restricted to necessary functions. Properly configured access control protects sensitive information while supporting workflow efficiency. Misconfigured permissions can lead to unauthorized changes, data loss, or security breaches, making careful management essential. Common use case scenarios illustrate how databases operate in daily business environments. A retail system may track sales and inventory through a central database, ensuring real-time updates for both in-store and online channels. A customer support center may log service requests and track resolutions. Educational institutions may store student records, attendance, and grades for reporting and compliance. Each example highlights how structured, accessible data supports efficiency and informed decision-making. On the Tech Plus exam, you should be ready to identify the benefits of structured databases over flat files, recognize components such as records, fields, and schemas, and understand concepts like persistence, concurrency, and validation. You may also need to distinguish between local and cloud database models, evaluating trade-offs in cost, control, and availability. Demonstrating familiarity with these fundamentals will help you answer both definition-based and scenario-based questions accurately. Key glossary terms for review include record, field, table, query, schema, index, validation, persistence, and access control. Grouping these terms by structure, performance, and security functions can make them easier to remember. Practicing with flashcards or real-world examples reinforces understanding and ensures you can apply the terms in context. In real-world IT operations, database knowledge benefits every role. Support technicians handle user access requests and assist with form design for accurate input. Administrators monitor performance, manage storage capacity, and enforce security policies. Analysts and developers depend on database accuracy for generating insights, running reports, and building applications. Understanding how structured data works allows IT professionals to maintain reliable systems and support the needs of the organization effectively. In the next episode, we will focus on database structures, comparing relational and non-relational systems, and explaining how each stores, links, and retrieves data. You will learn how structured, semi-structured, and unstructured data are handled differently, and how these differences affect performance and scalability. Join us for Episode 47, Database Structures, Relational and Non-Relational Explained. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.